So this video is going to be all about gases and gas laws. So let's briefly go over some solid, liquid, and gases. So firstly, with gases, they can expand due to the larger distance between the particles. Since they are far apart from each other, they can move around more freely. Next, we have liquids, which can change shape pretty easily since the particles are not in a fixed position, and they are closer together than gas particles. Lastly, we have solids, which have particles that are packed very tightly together, making it hard to move around. Thus, solids have a definitive shape. Some key properties of gases are that they are compressible, meaning you can force gas into a smaller volume with pressure. When heat is added, gases expand and the particles move faster and further apart. Gases also have very low viscosity, so they can escape a container very easily, as opposed to something thick like honey. Gases are also less dense than solids and liquids, and they are miscible. Gases can be defined by their pressure, volume, and temperature. In this case, pressure is caused by contact between gas molecules and their container. So atmospheric pressure is highest at sea level, and gravity is strongest at sea level, so pulls the molecules closer to the surface. So let's briefly go over some units of pressure. So 1 atmosphere is equal to 760 millimeters of mercury, which is equal to 760 torr, and so forth. So like a quick example, what is 732 millimeters of mercury in kilopascals? So we have 732 millimeters of mercury, and we multiply that by 101.325 kilopascals. And we divide that by 760 millimeters of mercury, which gives us 97.6 kilopascals. So a really important law that we use in gases is Boyle's law, which states that pressure and volume are inversely proportional under constant temperature. So as pressure increases, volume decreases. When you plot pressure versus 1 over volume, you obtain a straight line. So let's do an example. If 15 liters of gas at 80 kilos pascal is compressed into the pressure of 320 kilopascals, what is the new volume of the gas? So we have our P1, our V1, and we have our pressure too. So right now what we're looking for is our volume too. So if we plug everything into the equation P1 times V1 equals P2 times V2, we get 80 kilos pascal times 15 liters equals to 320 kilopascal times volume 2. Solving for volume 2 gives us 3.75 liters. Therefore, the new volume is 3.8 liters. Another important law is Charles' law, which states that volume and temperature are directly proportional under constant pressure. So as temperature increases, volume increases. Charles ran many experiments that showed that regardless of the gas used, the x-intercept in a volume versus temperature graph was always negative 273 degrees Celsius, which was interpreted by Lord Kelvin to mean that at negative 273 degrees, all molecular motion would stop. He called this value the absolute zero, as the kinetic energy and the volume of the gas would be zero. However, it's important to understand that real gases have volume, and as the temperature drops, the gases would condense. Kelvin used this information to create a temperature scale where Tk equals Tc plus 273, where Tk equals the temperature in Kelvin and Tc equals temperature in Celsius. So let's do an example. A 2.5 liter party balloon is removed from a room at 22.3 degrees Celsius and taken outside on a cold winter day. If the outside temperature is negative 3.6 degrees Celsius, what is the volume of the balloon now? So here are our givens. We are given volume 1 and T1, and we're also given T2. We're trying to find V2. So plugging in what we know in this equation, we have our volume 1 divided by our temperature 1, and that equals to volume 2 over our temperature 2. So solving for volume 2, we get volume 2 equals to be 2.28 liters, which is our new volume. Gay-Lussac's law states that pressure and temperature are directly proportional. So, as temperature increases, pressure increases. So, pressure is directly proportional to temperature, and our equation that we use for this is P1 over T1 equals P2 over T2. So let's do a final example. A gas at 225 kilopascals has a temperature of 26 degrees. If the pressure is decreased to 101 kilopascals, what is the new temperature of the gas? So we have our givens once again. We have our P1, our temperature 1, we have our second pressure, now we're looking for our second temperature. So plugging in our givens into this equation, we can find out that our second temperature will equal 134.22 kelvins. Therefore, the final temperature is 134 kelvin.